So this I got this delta WLS is given by, now again don't ask from where this derivation come or from where this relation came. It is again a concept from electrodynamics, directly borrowed from there. Scientists have used that, we have to use the same. If you want some more description about this or information about this, you can go for some standard reference book again. That reference books may give you some ideas about this type of relations which we have used here. Okay, and therefore here mathematically this delta WLS can be written as, now this is angular velocity omega, which we have written by equation number 11, and here this into, okay, this is not x, this is into S star, projection of this S star over h upon twice pi. This is quantum mechanical value of this angular momentum, spin angular momentum, into cosine of L star and S star. Okay, so write this, you try to understand this, like this is my S star, this is L star, angle between them is theta, therefore I am getting S star into cosine of angle between L star and S star. So this relationship, this is just what I have shown here, A bar and B bar. Taking projection of B bar on A bar, we write this to be projection vector is B bar into cos theta. In the same lines, I am using S star, projection of S star over L star by this factor. So it is S star into small s star into cosine of, instead of writing theta, I am writing cosine. Okay, call it to be angle between L star and S star. We don't know, we are not using any symbol there. We are directly calling angle between L star and S star. So projection of S star on L star is given by S star cosine of L star S star into h upon twice pi, that is the basic unit of the angular momentum. So S star into cosine of L star S star into h upon twice pi, that is what I have used it here. Okay, this is my one relation, call it to be equation number 12. Now replace this omega from earlier relation number 11. Here we will get delta WLS, therefore delta WLS is equal to, replace this W from above equation number 11, so I will get here to be 1 by 2 into L star multiplied by h cross is h upon twice pi, we are writing this later on, into ZE square divided by m square into c cube multiplied by 1 upon r cube. This is all my omega, already we have written that equation 11, multiplied by S star into h cross, h upon twice pi is h cross, into cosine between angle L star and S star. Okay, and here since h bar, h cross is equal to h upon twice pi, both relations have this h upon twice pi, so I am writing in shortcut, it is h cross. Then again rearrange all these things, therefore I'll get delta WLS is equal to, now this is z into e square divided by twice m square into c cube multiplied by h cross square multiplied by 1 upon r cube into, now this time it is L star S star into cosine of the angle between L star and S star. Remember, we are interested in this type of terms only. All things here are now not that they are important, but we are not needed to pay much attention about these type of things, which are going to be some constant numbers are there, like h cross, mass of electron, space of the speed of the electron, r is the distance from its nucleus, Ze is the charges contained by the nucleus, and all these things are found to be constant. So I'll get a relationship delta WLS, the spin orbit interaction energy delta WLS is given by this type of relationship here. Okay, so further I'll write this to be in a another format. So this h cross square can be written another again in this format as given in our book. So it is z into e square divided by twice m square c cube into h square upon 4 pi square, h cross is h upon twice pi, Therefore h cross square is h square upon 4 pi square into 1 upon r cube multiplied by L star into S star into cosine of the angle between L star and S star. Call this to be equation number 13. This is delta WLS, spin orbit interaction energy. Now here the distance r, we have to again go for approximation. Such approximation is again allowed by quantum mechanics, that is called as perturbation theory. So we are using this. The radial distance r, is function of z. Z is the number of protons contained by the nucleus. At that time concept of proton was not known, doesn't matter. So this r depends upon z. If z is smaller, r will be smaller. Z is bigger, r will be bigger. So it depends upon z, it depends upon n, principal quantum number, it depends upon orbital angular quantum number, and it changes continuously, in any given state. We have to get a average value of this. That's what I am mentioning here. Since the interaction energy, spin orbit interaction energy is very small, खूब छोटा है, but makes a lot of difference. Energy is very small as compared to total energy. Is a spin orbit interaction energy is very small. We are not written here. Okay? A spin orbit interaction energy is very small as compared to COMPARED. I is not there. Compared to the total energy, we need only what is needed just here to consider average value. As I said earlier, this entire derivation consists of many things which are not known to us in other branches of physics as well as mathematics. Still we are using them here to consider average value of delta WS, and therefore of average value of this r cube, 1 upon r cube, average value of 1 upon r cube again. And now how to get this 1 upon r cube value? Again there is a separate theory in quantum mechanics which is called as perturbation theory. Okay, so from perturbation theory in QM, from perturbation theory, some of you might be using this word for the first time, but there is one very interesting theory, one method of solving the problems in physics, that is called as perturbation method. So this method, according to this method, perturbation method theory in quantum mechanics QM, one gets this 1 upon r cube average. This is the way or the symbol used in quantum mechanics to write the average of the quantity. Some books write this to be 1 upon r cube bar. Okay, this way. This is also average, but we are not using this concept. We are using this symbol. Average 1 upon r cube is equal to, again see here, this is a lengthy derivation or relation which we are not deriving anywhere here, but we are directly taking it from z cube upon, this is e1 raised to 3 n cube multiplied by L, principal quantum number, orbital angular momentum quantum number, into L plus 1/2 multiplied by L plus 1. Okay, this is another relation. Here I am giving number to be, this is 14. So don't derive this from anywhere. For that you have to learn first quantum mechanics. In the quantum mechanics you will come across this perturbation theory, and for such a problem of electron revolving around nucleus, this perturbation theory gives the average distance 1 upon r cube, average of this 1 upon r cube, or r is the distance between that nucleus and electron. So its average, third power average, its reciprocal is given by z cube upon e1 raised to 3 n cube into l plus 1 into l plus 1 half. Okay, so the symbols have their usual meaning. Okay, where this a1, where a1 is the Bohr radius of first orbit, and which is, I know that the expression for that, which is h cross square upon mc square, which is h cross square upon mc square, and therefore I can use this equation number 13. I can use this E1 in this above equation 13 by h cross square upon mc square in this equation number 13. So use equation 14 and this quantity h cross square upon mc square in equation number 14. We get this delta WLS. This is called as delta WLS. It is average interaction energy. Delta WLS is equal to, write it later on. Now this is Z into E square divided by twice m square c cube into h cross square again multiplied by this now z square, this is z cube divided by this E1 cube into n cube multiplied by L, this I am writing 1 upon r cube average, into L plus half into L plus 1 multiplied by this factor remaining L star S star into cosine of the angle between L star and S star. So give a number to this is equation number 15. Okay, don't worry if it even it appears to be larger one, we are not interested more in mathematics, we are interested more in physics and how the splitting of energy level occurs. That is the most important point of us that is to be considered. So for the factor, now next is for the factor L star S star into cosine of the angle between L star and S star, we turn to the vector atom model. How? For that we have to use this particular diagram, as already we have discussed one of the diagram there, but here I am drawing one more diagram as seen there. Okay, now for a simple case I can show here there are three vectors. This is my one vector, this is the another vector. Okay, suppose this is S star, this is L star. Now I can complete this parallelogram to get the resultant, which is called as the J star. So complete this parallelogram and get this vector which is drawn here. May not be a straight line in my diagram, but you can draw it straight line. So this is my J star, resultant of this. And now what this precision is? Precision means this S star, okay, this S star vector rotates about this direction of J star in such a manner that it completes one cone here as shown by this. So connect this and this by dotted lines, you will get this. Similarly, this L star also rotates about this J star in such a direction, in such a way that also forms one such cone. That also forms one cone. So complete this cone too. So this is what here I am using. This is the vector atom model where we have taken this. I know that vectorially J star is equal to L star plus S star, okay, vector addition. So, or that is J bar is equal to L bar plus S bar. Vector addition of this gives me J star. So I have drawn this vector diagram where L star and J star are shown to be two vectors. Resultant of them is to be J star by taking this law of parallelogram of addition of vectors. And here I have shown this both S star and L star, they precess around J star, means I can take this one combination, another combination that this S star gets shifted here, L star gets shifted here, still I am getting J star. If you are getting this another value in between, मधली कुठलीही व्हॅल्यू घेतली तरी या दोघांचा रिझल्टंट हा नेहमी J star येणार आहे. So this is the vector atom model we are using here, okay. So we are using this concept from quantum mechanics or vector atom model, where we get the total orbital angular momentum is equal to orbital angular momentum plus spin angular momentum, okay. This is the vector atom model. We are taking this particular concept here. So right here in field free space, both L star and S star, precess around their resultant J star, okay, according to the law of conservation of momentum. Remember, I am explicitly writing each and every statement from the textbook. Without that, it is very difficult to understand this derivation. That's why we are writing almost each and every line here. According to the conservation of angular momentum, the resultant J star and hence angle between L star and S star, okay, this is the angle between L star and S star, okay. Angle between L star and S star always remain invariant as shown in diagram, okay. Remember, that's why we could draw this diagram here. ही diagram आपण याच कारणामुळे काढू शकतो की there is a principle of conservation of angular momentum, and that principle tells you this J star is always equal to L star plus S star. Angle between them must remain invariant. Then and then for any pair of L star and S star, I'll get same resultant J star. That is the meaning of this particular statement what we have written here. And therefore we have drawn two cone that is traced by this S star around J star, a cone traced by this L star around J star, and any of the या कोन वरचे कुठलेही दोन वेक्टर्स घ्या त्यांची ॲडिशन तुम्हाला नेहमी J star मिळेल. And that's why this is the vector diagram I could plot because of this principle of conservation of angular momentum. So this is how in this field free space both L star and S star precesses around their resultant J star. According to the law of conservation of momentum, the resultant J star and hence angle between L star and S star always remain constant. So out of these one pair is shown, L star and S star. There can be several pairs. There can be several pairs can be of this S star and L star are taken on this cone where this angle between S star and S star is remaining fixed, and their resultant also shown to be same, that is J star. And that's why we could draw this diagram as shown here, okay. And therefore further statement we can write here using the cosine law for this diagram, using the cosine law, okay. I think most of you might not be knowing this. J star square is equal to L star square plus s star square plus twice L star s star into cosine of angle between L star and S star. Now how to understand this? Suppose I am given this is vector A bar, this is vector B bar. Complete this parallelogram and you will get the resultant obtained here R. So this R square is given by A square plus B square plus twice A into B multiplied by angle between them, that is cos theta. So this is what this is what we do. This is what our parallelogram law of addition of vectors. We get the resultant R square is equal to A square plus B square plus twice AB into cos theta. Here same relationship, J star square. As I know, J star vector J star bar J bar is the resultant of L bar and S bar. Then I can write same relationship here, J star square is equal to L star square plus A star square plus twice L star S star cosine of angle between L star and S star. We are more interested in this term, as I said earlier, because that also appears in our interaction energy term. Therefore we can write further here L star into S star multiplied by cosine of the angle between L star and S star is equal to, it is J star square minus L star square minus S star square. Take all these quantities here divided by this is 2. So call this to be equation number, number there. What is our earlier number? This is 15. Here it is 16 and 17. This is our 16 is law of parallelogram of addition of vectors. 17 is this factor which I have used there. Okay, and now use this equation number 17 as well as that average 1 upon r cube. Okay, so that average what we have equation number we have to write. This is average. Okay, average 1 upon r cube. This is equation number 14 and equation number 17. So using equation 14 and 17 in our equation, this equation number 15, using equation 14 and 17, equation 14 and 17, in equation 15 we get, not what is we get is this delta WLS. Now this time it is average because I have used the value of 1 upon r cube average. So it is delta WLS is equal to, now replacing all these numbers, one will get Z into E square divided by twice M square into C cube multiplied by H cross square, this term is as it is, multiplied by Z cube. Okay, this is what 1 upon r cube, average 1 upon r cube. It is A1 cube into N into L into L plus half into L plus 1 and multiplied by, now this L star A star into the cosine of the angle between L star and S star, that can be replaced by this equation 17 here. So it becomes J star square minus L star square minus S star square upon 2. And here further we can adjust some things as like here delta WLS average is equal to some R into alpha square divided by CH into Z raised to 4th, okay, cube and this one of the Z, we are adjusting all these things, so it is here, then N cube multiplied by, okay, here in this derivation this is A1 cube, N cube is there. I think everywhere we miss this, आपल्याला मागच्या ह्याच्यामध्ये पण तो मिस झाला राहिलेला आहे, because that's as we have written equation number 15 मध्ये आपण लिहिला आहे तो, that is N cube is there, so here it is also N cube. So N cube then it is multiplied by L into L plus half into L plus 1 multiplied by J star square minus L star square minus S star square. Now this is now equation number 18, where I have put this constant r is equal to twice pi square m e raised to fourth divided by ch cube. Okay, adjusting this is called as a Rydberg constant, Rydberg, Rydberg's constant, which we have seen earlier in chapter number 1. And another constant is alpha square. Alpha square is another very important constant in physics, and this alpha square is square of the fine structure constant, and it is given by 4 pi square. So adjusting both of these, m e raised to fourth divided by c square h raised to fourth, this is called as square of fine structure constant. Fine structure constant. I am sure in the first look or the first instance it is very difficult for anyone to understand this entire derivation. That's why I have broken this derivation in 2 lectures, आणि त्याच्यामध्ये सुद्धा आपण पुन्हा खूप स्लो जातो आहे, बिकॉज मोस्ट ऑफ द थिंग्स आर नॉट, वी हॅव नॉट स्टडीड, सायंटिस्ट हॅव स्टडीड अँड दे हॅव यूज्ड ऑल दीज थिंग्स दॅर. ओके, सो ही जी आता वरती टर्म आले डेल्टा डब्ल्यू एल एस बार. ओके, दिस इंटरॅक्शन एनर्जी delta WLS average or bar is also called as another term you are using here, term shift, HHIFT. And now this is the very common word we are going to use further in all the chapters 4, 5, 2, 3, 4, 5, 6 and everywhere. So this average interaction energy delta WLS bar is called as term shift, and give this number to this equation. Actually I have given this, yes, equation number 18. Now dividing equation 18 by product HC, dividing equation 18 by Planck's constant into velocity of light, this product HC, we get term shift in wave numbers. As okay, wave number is reciprocal of the wavelength, so we get these entire things in terms of this reciprocal of wavelength or in terms of wave numbers. And for that now another symbol is used, delta, this is gamma, okay, and L comma S to indicate this is the wave number because of the spin orbit interaction. So wave number or the term shift in terms of wave numbers because of the spin orbit interaction, delta gamma ls is equal to, and if I have to write this entire relationship, this becomes minus r into alpha raised to 2 into z raised to 4th divided by n cube into L plus half into L plus 1, this all these things as it is, multiplied by j star square minus L star square minus S star square. Okay, and this negative sign, from where this negative sign comes, negative sign indicates the conversion, okay. Try to understand, this is most difficult derivation from this entire syllabus of atomic and molecular physics or atomic and molecular spectra. As I said earlier, no one also asked in examination, no one asked this entire derivation. It is not possible for anyone to solve this derivation without looking inside the books, but part of that may be asked, application of that may be asked, and that is what we are going to concentrate more later on. So the negative sign indicates the conversion that the term values are measured from series limit downwards. Okay, try to understand. You will not understand meaning of this word here, but as and when we will go for the actual spectrum of one valence electron system, two valence electron system, or some special elements like sodium, potassium, etc., in that case when we draw this type of energy level diagrams, then what is the series limit downwards? There is always a series, and the limit of the series is always there. The downward limit of the series is taken, and in that concern this number is calculated, wave number is calculated. That's why negative sign comes there. Don't again misunderstand that we have not known, आपण त्याच्याबद्दल काही शिकलेलं नाही. We are directly using this concept there as what is used by all this. Okay, so this gamma factor, not F, okay, gamma factor indicates spin orbit interaction energy. Spin orbit interaction energy. Spin orbit interaction energy. Okay, so remember the format. त्याचा फॉर्मॅट फक्त लक्षात ठेवा, बाकी तुम्हाला काही लक्षात ठेवायची गरज नाही आहे. In short, I can write this gamma is equal to A times L star into S star multiplied by cosine of the angle between L star and S star. Or another relationship we can write for this gamma factor is equal to A times in the bracket J star square minus L star square minus S star square upon 2. This factor, okay, this can be expressed by this J star square minus L star square minus S star square, where this entire quantity E is a constant and which is given by capital R into alpha raised to 2 Z raised to 4th divided by n cube multiplied by L into L plus half into L plus 1, then multiplied by and centimeter raised to minus 1, because this is going to be a number. Wave number has always dimensions of 1 upon meter raised to minus 1 or 1 meter raised to minus 1 or centimeter raised to minus 1. This is a number per centimeter. Wave number is, that's why centimeter raised to minus 1 is the unit of this constant, that is given to be E. Okay, now we'll just write further, we'll just complete the derivation and we'll come across another point. The term value gamma, okay, not F, gamma, this is a letter, Greek letter here, measures separation from hypothetical center. I'll draw one such diagram, then you will understand this. Hypothetical center with term value gamma 0. Thus the separation, we'll mark done diagram, then will it make clear to you. Thus the separation in terms values due to spin orbit interaction. Spin orbit interaction is, okay, this is gamma J is equal to gamma 0 central value minus this gamma, okay, gamma 0 minus gamma. Okay, so try to understand what is this. या सगळ्यांचं meaning काय आहे, याला एक number द्या वरच्या equation ला. This is what I am interested in, this relation, this gamma factor. This is this relationship 18, 19, 20. Now this is 19 and this is equation number 20, both this set, this is, or the entire thing, this is equation 20. So almost it requires 20 different equations to come across this. Now here in this case, now what is this? For example, इन द पी स्टेट, आता आपण एक्झाम्पल घेणारच आहोत सोडियमचं, त्या केसमध्ये वी आर गोइंग टू ड्रॉ दिस टाइप ऑफ डायग्राम. दिस डायग्राम टेल्स यू व्हेरी इंटरेस्टिंग थिंग because of this spin orbit interaction. So draw this diagram first, we will understand what we are doing here. Just a minute, I'm not getting this here. Why it is not coming there? Pointer is not showing. Yeah, this pointer is now there. Here I can draw this as, this is my gamma 0. So this is your okay, actual P state. P means SPD, that is L equal to 0 state is there. Because of this spin orbit interaction, these states get splitted. Okay, one is shown by this, it is doublet P3 by 2. So this is my A by 2 separation, and here it gets separated. Here it is separation A shown to be little bigger, and this is its state, it is doublet P1 half, doublet P1 half. So in general, and this separation is given by gamma. Okay, what we have written here, gamma is this gamma. And remember, म्हणजे याचा अर्थ काय, when this spin orbit interaction is not there, this is the term value, that is the actual energy level for that particular electron. But because of this spin orbit interaction, now this particular energy level gets splitted by this, okay, A by 2 and A etc. So this total difference will be A plus A by 2 is 3A by 2, म्हणजे हा सगळा डिफरन्स एवढा असेल. अँड बिकॉज ऑफ दॅट, आता जेव्हा केव्हा याचं ट्रान्झिशन व्हायचं असेल, इफ द स्पिन ऑर्बिट इंटरॅक्शन हॅड नॉट बीन देअर, आय कुड हॅव गॉट ओनली वन सिंगल frequency here n. Okay, but whenever this electron either goes in this state or it goes in this state, depending upon that, there is a possibility that we can get a transition from this to this, we can get a transition from this to this. And here it is n prime, n1, and this is n double prime. So difference between n and n double prime is now proportional to this splitting. याच्यामध्ये किती स्प्लिटिंग आहे तेवढा तो प्रपोर्शन असेल. ऑफकोर्स दिस डिफरन्स इज गोइंग टू बी व्हेरी व्हेरी स्मॉल, बिकॉज द स्प्लिटिंग ऑफ दिस लेवल, जरी मी डायग्राम खूप मोठी दाखवली असली तरी एवढं स्प्लिटिंग नसेल. व्हेरी स्मॉल स्प्लिटिंग ऑकर्स in this energy level because of this spin orbit interaction, and thereby two spectral lines are possible. Otherwise, if this spin orbit interaction is not known, ती जर आपल्याला माहित नसेल किंवा अशी इंटरॅक्शन झाली नाही तर एकच स्पेक्ट्रल लाईन तुम्हाला मिळेल. हियर इन दिस केस वी आर सपोज टू गेट डबलेट. So this is singlet here, single line, and this is possible doublet here. So this phenomenon observed in this one valence electron system, and this could be explained by the spin orbit interaction only. So almost for 100 years, I am saying 100 years, this problem of doublet was there in the spectroscopy. People were not able to give the explanation why such type of doublets are occurring in such element spectra where one valence electron system is there. But as and when this particular quantum mechanics came, this electromagnetics came, this Larmor precession is understood, other concepts of the mathematical theory, physical theory etc. were taken in consideration, and then people could calculate this type of the splitting that is occurring because of the spin and orbit interaction. As I said earlier, this interaction itself is very very small as compared to total energy of the electron. But this small fraction of energy changes energy levels of the electron in the higher orbit states or higher orbits or excited states, and this gives rise to a doublet or triplet or multiple type of spectral lines etc etc. So one valence electron system, the splitting of spectral lines or the doublet spectral lines, that is possible because of the splitting of energy level, and that splitting is caused by the spin orbit interaction only. So this entire spectroscopy was known for more than 200 years, and only in the last 100 years, around 1920 1930 somewhere, people could give successful explanation of the doublet observed in the in the single one valence electron system, and therein they considered the spin orbit interaction is taking place. Because of that, we are getting such type of complicated spectrum for one valence electron system. Otherwise, spectrum of these elements and spectrum of hydrogen atom would have been same. सारखाच असायला पाहिजे होता, परंतु तो स्पेक्ट्रम सारखा नाही. याचं कारण असं आहे की शेवटचा जो ऑर्बिटमध्ये इलेक्ट्रॉन असेल त्या इलेक्ट्रॉनला आता जेव्हा तो एक्साइटेड स्टेटमध्ये जाईल त्यावेळेस त्याला सिंगलेट स्टेटच्या ऐवजी डबलेट स्टेट्स आर अवेलेबल. सो दिस इलेक्ट्रॉन कॅन गो आयदर हियर और it can go here depending upon transition from this to ground state. Doublets ought to be there. So this explanation of observation of doublets in the single valence electron system, this could be given or this could be explained by this type of effect, which is called as the separation of energy levels, or which is called as the spin orbit interaction. Okay, and last point we'll write here in many short. It is observed that okay, my request is that please read all this article from your textbook. तुमच्या टेक्स्टबुक मधून किंवा विकिपीडियावरती जरी तुम्ही हे वाचलं तरी कळेल. मला माहिती आहे की पहिल्या इन्स्टन्समध्ये कोणालाच हे डेरिव्हेशन फारसं समजत नाही. नॉट इवन टीचर्सना सुद्धा तेवढं डेरिव्हेशन लगेच समजत नाही. वी हॅव टू थिंक व्हेरी मेनी टाइम्स ओव्हर दॅट ईच अँड एव्हरी आस्पेक्ट यूज्ड, and then sometimes we get an idea why these doublets are observed in this spectrum here. Okay, it is observed that first observation, the separation increases. This separation increases with increase in atomic number. म्हणजेच अशा एका पी लेवलचं सोडियमचं सेपरेशन आणि अशाच एका पी लेवलचं पोटॅशियमचं सेपरेशन यातला हा तो गॅप वाढत जाणार आहे. सो ॲज वी इन्क्रीज द ॲटॉमिक नंबर, दिस सेपरेशन स्पिन ऑर्बिट सेपरेशन interaction separation increases. This is one observation. Second is the separation decreases. Not like this. Separation decreases with increase in principal quantum number. Principal quantum number n. So as n increases, that means if I have 3p, then 4p, this energy levels, then 5p, etc. Now here the separation is like this, bigger. When I go for 4p in the same atom, now this separation becomes smaller. In the same atom, separation for the energy level 5p will be smaller. So that is how here it is bigger, here it is smaller than that, and here it is still smaller than that. So as we increase this n, okay, n is the principal quantum number, 3, 4, 5, etc. This separation goes on decreasing. As we go across different elements, as atomic number goes on increasing, the separation goes on increasing. And last observation, C, the separation decreases. The separation decreases with increase in L. म्हणजे ऑर्बिटल अँग्युलर क्वांटम नंबर वाढला त्याच प्रिन्सिपल क्वांटम नंबर बदला की सेपरेशन कमी होत आहे. त्यानंतर प्रिन्सिपल क्वांटम नंबर वाढला त्याच ॲटम मधला तरी सेपरेशन कमी होत आहे. आणि जर ॲटॉमिक नंबर वाढवला तर मात्र प्रत्येक या प्रकारच्या लेवल्स मधलं सेपरेशन हे वाढत जाते. दीज 3 observations are there, and this is one typical diagram we have shown here where the spin orbit coupling or spin orbit interaction energy, how it gives rise to a doublet energy states, and thereby the spectrum of such type of elements is found to be a bit complicated. Okay, so in that sense I'll just show one level diagram. Actually we have at the end of this we should go for this. मी आता थोडंसं एक डायग्राम तुम्हाला नव्याने दाखवेल. Just let me check this diagram how it comes there. See this. Are you looking? दिसतंय का सगळ्यांना? Anyone? कोणी सांगताय का? How many are there? Only 5. Only 2. Pratidnya आणि Rishi. Only 2 students are there. It's very horrible picture. खूप वाईट गोष्ट आहे. ओके ओके आय थिंक आय शॅल स्टॉप हिअर. मी आता इथं थांबतो. पुढच्या वेळेस आपण ह्याच्यामध्ये जास्त हे बघूया. ओके जस्ट मिनिट, लेट मी टेक द अटेंडन्स, अदरवाइज इट इज नॉट. Okay, we'll stop here. This is the sodium spectrum. We will discuss the spectrum in the next lecture. That's all.